Right, good afternoon, class. Today we're looking at exercise 4.1 on page 84. We're dealing with coordinate or analytical geometry. The question says calculate the distance between the following pair of points. Give your answer in simplified third form if necessary. So at this point you should have been exposed to the distance formula. The distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. This is a distance formula. Okay? Write it as often as possible down so that you guys will remember it or memorize it in the process. Okay? So in looking at number 1a, I'm just going to do a few selected sums. I'm not going to do all of it. So otherwise we're defeating the purpose of what we're trying to do here. Okay? So 1a. So we got a coordinate, which is negative 1 and 2, and b's coordinate is 4 and 14. Okay, so again the distance formula, I'm just going to write it down a few times. Thereafter I would expect for you to do it all the time. Okay, so it's going to be x1 plus x2 squared minus plus y1 minus y2 minus y1 squared. So remember, if you had made this x1, this will be y1. If that's x2, y2. However, if you're going to place this to be x2, then this must be y1. If you made this x1, that will be y1. Okay? So x2, y2, x1, y1. Or x1, y1, x2, y2. Okay? So we go. x2, which is 4 minus 1, which is plus 1 squared, plus 14 minus 2 squared. Okay, so you can put it in the calculator. So it's going to be the square root of 5 squared, which is 25, plus 12 squared is 144, is 169, which is 13. Okay, let's check here. 4 plus 1 squared plus, you would have put this in the calculator and get your answer straight, you would have gotten the full mark anyway. 30. Okay, let's look at 1c. Okay, in 1c we are given x to be 5 and minus 2 and y to be 11 and 6. Okay, so again the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. If I had made this x2, it's going to be 11 minus 5 squared plus 6 minus 2 squared. Okay. If you mix up your numbers here, it's not going to make much of a difference. Okay. Because of the squared, if it's negative, it will become positive anyway. Okay. So that's going to give you 6 squared, which is 36. Plus that's 80, 64. It's 100. Gives you an answer of 10. Okay, do we have to do that intermediate step here? No, you don't have to. Okay, 11 minus 5 squared plus, I just like checking to make sure that the answer is correct. Which makes that right. So it's 1 C D E. Let's look at E. It's going to be 4 and negative 7, and D, which is 1 and 2. Okay, so distance formula for CD will be the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's going to be 1 minus 4 squared plus 2 minus 7 squared. Okay, so that's going to give you the square root of 9 plus, that is 9 is 81, is 90, is 3 root 10. Okay, let's just check. So it's the square root of, upper brackets, 1 minus 4 squared plus 2 plus 7 squared, 3 root 10. Okay. If you have made any errors or mistakes, you can get me on that number. Otherwise, these videos are free. Okay. Or if there's an easier way or something I've explained wrong, Again, get me on that number, okay? If you have a better explanation or I have a misunderstanding, I'm open to be corrected, okay? Okay, so number 2a, calculate the coordinates of M, the midpoint of line segment, joining the following pairs of points. So the midpoint follows a formula. The midpoint of AB is going to be x1 plus x2 over 2, y1 plus y2 over 2. Okay? So the midpoint of AB, again, if you made that x1, that will be y1, and so on. Okay? So it's going to be 1 plus 5 over 2, 6 plus 8 over 2. It's not going to make a difference here if you mix it up here as well. Okay, but just make a habit of doing things properly. So it's going to be 3. That's going to give you 7, I think. That's 14, yeah. 2c. 2c is going to be L, which is negative 3 and 5. And N, which is negative 7 and 2. Okay? So the midpoint of Ln is going to be x1 plus x2 over 2, y1 plus y2 over 2. So the midpoint of Ln, it's sum to be negative 3 plus negative 7 over 2, 5 plus 2 over 2. So midpoint of Ln will be negative 5 and 7 over 2. Okay? That's 2c, d, e. Let's look at E. E's coordinate is G, which is 4 and negative 5. And H is going to be 3 and negative 4. Okay? Oops. So the midpoint of GH will be x1 plus x2 over 2, y1 plus y2 over 2. Midpoint of GH, of course, is going to be 4 plus 3 over 2, minus 5 plus negative 4 over 2. So the midpoint of GH will be 7 over 2 and negative 9 over 2. Now we're going to look at, let's just change the color here, number 3a. Okay. Number 3, we are told in each of the following cases, M is the midpoint of the line segment PQ. Calculate the values of x and y. So here, this is as if you got this line here. P, you got negative 2 and 6. M, which is 3 and 4, as you know, that's the midpoint. And Q is x and y. Okay, so that's the scenario you have there. Remember, this is the midpoint, so you must use the midpoint formula. Okay, because of space constraint here, I'm not going to write down the formula, but we know it's x1 plus x2 over 2 will then give me the x midpoint. In this case, it's going to be 3. It's 3 over 1, so I cross multiply. So negative 2 plus x equal to 6. So x is equal to 8. Okay. So x is 8 in that case. Here we're going to say that y1, which is 6, plus y2, which is y over 2, is equal to the y mid, which is 4. Actually, that's over 1 across multiply. So 6 plus y times 1 is 6 plus y, and 2 times 4 is 8. So y is equal to 8 minus 6, which is 2. Okay. I'll carry on in the next video with the remaining sums of this exercise.